Hello, hi, good morning, good afternoon, good evening. This is Thacienne. I'm here again. Welcome back to Mathify Analytics. In today's presentation, we are going to continue answering the questions of the National Examination of Mathematics for the year 2022-2023. For those who didn't watch our previous video, in our previous video, we answered questions from 1 to question number 6. And today, we are going to try to answer questions from number 7 to question number 15. So, if you didn't watch our previous video, I recommend you to watch it too if you are aiming to learn. Yeah, but don't worry. If you didn't watch it and you don't want to watch it, you can just watch this one and see how we are going to solve these questions. Yeah. I'm sorry again. I will be mixing languages, Kinyarwanda and English, and I think you are okay with it. Yes. If it's your first time to be on this channel, don't forget to subscribe. Subscribe to our channel and turn on notification bell so that you will get notified anytime we upload a new video. If you like our videos, don't forget to click like and share the video to your friends and colleagues and let them that we are solving these questions so that they can come and we prepare the exam together. So stay tuned and don't go watch the video from start to the end. So we are starting from question number 7, and question number 7 was about, let's see, what was it? Question number 7, from the top of a cliff 100 meters above sea level, the angle of depression of a ship sailing past is 17 degrees. How far is the ship from the base of the cliff to the nearest meter? I don't know if all the students in Rwanda, my dear students, are understanding this question. Do you know what is a cliff? Ntabwo nzi niba rwose abana b'abanyarwanda siritu abatuye mu byaro kuko nta biyaga byinshi bihari ntabwo nzi niba tuzi cliff icyo ari cyo. Iki kibazo mwagiteguye please. A cliff, what is a cliff? Okay, now let me try to show you what is a cliff so that we will be able to understand this question very well. I ask Google a cliff. Cliff. Let's see some images of cliffs. Yeah, yes, maybe I can open which one. Let me open this one. Is big. Oh no, this one is not better. Maybe let me take this one. Yeah, and I make it bigger. A cliff, yes. I hope you are seeing this image clearly. A cliff. Cliff, urabona kino kintu cy'ikimanga kiri ahangaha, niba ari igisozi, niba ari n'urutare, niba ari iki, bene ibi bintu biba biri impande y'inyanja cyangwa impande y'ikiyaga nibyo bita cliff. Urabona amazi ahantu ari ni hano hasi. Noneho rero mu kibazo cyacu bari kutubwira ngo kuva hano hejuru hari uriya muntu ahagaze, kumanuka straight ugera hasi ku mazi hari metero 100. Noneho hakaba hari ubwato buri hariya hirya mu kiyaga cyangwa mu nyanja, wenda tuve kuko hari ubwato buri hano ahantu gutya. Ahangaha ndi gukora ndakeka muri kuhabona. Bakatubwira bati umuntu ijisho rye riri hano ahangaha hari ibirenge by'uyu muhungu cyangwa se wenda simbizi niba ari ku mutwe we ariko cliff ifite metero 100. Reka tuve ku ijisho riri hano hejuru kuri cliff, akaba ashaka kureba aho ubwato buri hano. None baratubaza bati kuva hano kuri base ya cliff, the base of the cliff is here, kugera aho ubwato buri somewhere here hari metero zingahe, niba ijisho riri kugenda rikurikiye angle of 17 degrees, kumanuka gutya harimo angle ya 17 degrees, hanyuma metero kuva hano hejuru kugera hano hasi hareka metero 100, bakatubwira kuva hano no kugera ahangaha hari metero zingahe. Ikibazo ngo nguko cyari giteye. So let me try to sketch this. And see if we can go deeper in this question. Dufite ibintu bimeze gutera. I take this pen. Let's take this like a cliff, and no. Yes, and this is the base here. This is the base of the cliff, sea level. This is B, the base. And tuvuge ko ubwato buri mu mazi, hano ni mu mazi, ubwato tuvuge kuko buri hano at this position. I call it S, the ship position. And this is the observation point. This is the top of the cliff. I call it P. Tuvuge ko umuntu ari kureba aturutse ahangaha akareba nyine akagenda agakubita ijisho rye rigakubita hano hasi ku bwato. Hanyuma icyo bita sailing angle ni angle iri hano hejuru. If we go horizontally like this angle, this is the sailing angle, and they say that the sailing angle is 17 degrees. This is 17 degrees, and this cliff has 100 meters. Hanyuma bakatubaza ngo kuva kuri B kugera kuri S hangana hati. I call it X, this distance. Then they ask X equal to what? That's the question. In geometry niba imirongo, if this line, I mean this and this, they are parallel, then this angle 17 degrees and it will be equal to this angle, which means that here we have also 17 degrees. Then with this measurement, with 17 degrees and 100 here, and then we can get X. All what we know in trigonometry is that the tan of the angle 17 degrees will be equal to what? It is equal to opposite side. Then the opposite side is the side BP. It will be equal to the side BP over the adjacent side, and the adjacent side is the size BS. No, not B, BS. I can see BS, yes. So this is equal to BP is 100, the length of the cliff, then over BS, and BS is X akaba ariyo tutazi turimo gushaka. So then from this you can see that X will be equal to 100 over tan of 17 degrees. So that was it. And if you have a calculator, then you can compute this value and give your answer in meter. The answer should be in meter. So that was it. Yes, next question number 8. Use Gauss-Jordan method of elimination to solve this system. We have a system and they want us to solve it using Gauss-Jordan elimination method. I think you remember how the Gauss-Jordan elimination method works. If you don't remember, it's your time to follow this question and see how we are going to use the Gauss elimination method. So we have a system. The system is the system is, where am I typing now? Oh yeah, the system is minus, let me write it here, minus 3x minus 2y and plus 4z equals, this is z, not 7, z equals to 9. This is the first equation. And the second equation is 3y and minus 2z equals 5. And the other system is 4x and minus 3y and plus 2z equals 7. This is the system that we have, and they want us to solve it using Jordan-Gauss elimination. What we have to do, we have to first to write the augmented matrix from this system. And the augmented matrix from this system will be minus 3 and minus 2 and 4 and 9. Yes, and 0. We don't have x in the second equation, and 3 and minus 2 and 5 and 4 and minus 3 and 2 and 7. This is the augmented matrix that we have. Yes, and usually separated this way. Yeah, so when we are asked to use the quotient elimination method, we aim to turn these numbers, we call them pivot numbers. We need to transform these pivot numbers into ones. These are pivots, and the pivot numbers, then the pivots should be equal to 1. We have to change them so that they be equal to 1. And we need to change this lower part, at least the lower part, or you can choose to change the upper part, but I choose the lower part. You change the lower part to be, all these numbers to be equal to zeros. You try to change them so that they will be zeros. Okay, and you have to start from the first row. If we start from the first row, we want that this element minus 3 be equal to 1. If we want it to be equal to 1, what can we do? We can divide the first row by minus 3. So we want that the first row number 1, will be equal to minus 1 over 3 times row 1. We take each element at row number 1 and we divide it by minus 3. If we do so, the first element will be equal to 1, and the second element will be equal to 2 over 3, and the other element will be minus 4 over 3, and the other element will be minus 3. Right? Yes. And we fix the second column and the second column and the third column. Then minus 2, 5, and 4, and minus 3, and 2, and 7. Yes, this is the first step. And then the next step, we transform. After transforming this number into 1, we need to transform these two numbers into zeros. This one is already 0, so then we don't need to do anything on the second row, but we need to change this 4 into 0. To change 4 into 0, we need to take, so then we will have L3 should be equal to, we need to subtract 4 to this 4 so that we get 0. So then we need to take R3 and subtract 4 times R1. Yes, so if we take 4 times 1, we will get 4, and then 4 minus 4, it will be equal to 0. And we have to do it for all elements of the row number 3. So what will we get? Okay, the first row is fixed. Then the first row is 1, 2 over 3, and minus 4 over 3, and minus 3. The second row is also fixed. Then 0, 3, minus 2, and 5. And then the third row it's obtained using this transformation. Then what do we get? We get 0 here, and the next one will be minus, let me calculate it. I write here, maybe I write here, it will be minus 3, I mean this number, then minus 4 times this, 2 over 3. This will be equal to what? This will be equal to minus 9 and minus 8, yes, over 3, which is equal to minus 17 over 3. So here we get minus 17 over 3. And we do the same to the second element, the third element I mean here. Then we take 2 and subtract 4 times minus 4 over 3. It's this one, minus 4 over 3. I'm using these 2 and this minus 4 over 3. Then this will be equal to, this is equal to 3 times 2, it's 6. And minus 4 times minus 4, this is 16, then plus 16 over 3. And this is equal to 22 over 3. Yes, right? Then we get here 22 over 3. And then we move on to this one, 7. Then this is 7 minus 4 and times this one. Minus 4 times minus 3. And this is equal to 7 plus 12, which is equal to 19. So we get 19 here. Good? Great? Yes. And then next step, we will have to change this number 3 into 1. We need this one to be equal to 1. So we fix the R1. R1 will stay R1, but R2 then will be equal to 1 over 3 R2, and we fix the R3. R3 is fixed. And what will we get? What do we get? So R1 is fixed. We have the first row is fixed. Murongo wa mbere turawurekera ukuri, ubwo ni rimwe, and then 2 over 3 and minus 4 over 3 and minus 3. But the second row, umurongo wa kabiri turagenda tugabanya gatatu kugira ngo tubone uko tubona rimwe hano. So then this is 0 and this is 1, and the next one is minus 2 over 3, and the next one is 5 over 3, and the next row is fixed. Then 0 minus 17 over 3 and 22 over 3 and 19. Yes? Yes. And then next, what do we do? Next, since we have 1 here, we need to change this number into 0. How do we change it into 0? Since we have minus 17 over 3, to get this number equal 0, we have to add 17 over 3. So we take this, we fix 0, 1, and R2 also is fixed, but then R3 will be equal to R3 plus 17 over 3 times R2. Yeah, because here we have 1, then if we multiply by 17 over 3, it will be 17 over 3 and minus 17 over 3, then we will get 0. If we do so, what do we get? The first row is fixed, so then the first row is 1, 2 over 3 and minus 4 over 3 and minus 3, and the second row is 0 and 1 and minus 2 over 3 and 5 over 3, but the third row is changed. And we are going to to transform it using this transformation. Then this will be equal to 0 and this will be equal to 0, but the next one will be equal to, this is 22 over 3 and plus 17 over 3 times R2, that case that is minus 2 over 3. Yes, so this one will be equal to, here we have 3 times 3, the common denominator will be 9, then 9 divided by 3 is 3 times 22, this is 66, and 17 times minus 2, this is minus 34, then over 9, which is equal to, this is 3 and 2, 32 over 9. So we get here 32 over 9. 32 over 9. And here what are we going to get? We will get, let me compute it here. We have 19, then plus 17 over 3 times 5 over 3. This one will be equal, the common ratio is 9, and 9 times 19, we have 180, then 171, and then plus 17 times 5, this is 85, and then this one will be equal to, we have 6 and 5 and 2, 256 over 9. So then we have here 256 over 9. Yes, all right. And then, since we are almost at the end, and we also have to change this number into 1. To get 1 here, we need to multiply by 9 over 32. So then we fix the first row, fix the second row, and the third row will be equal to third row 9 over 32 times third row. This is 9 times third row. So if we use this transformation, what do we get here? This number will be changed into 1, but then this one will be equal to what? Let's see. But let me first fix the first row and the second row, and then go ahead and transform the third row. If we fix the first row, we will get 1 and 2 over 3 and minus 4 over 3 and minus 3, and the second row is 0 and 1 and minus 2 over 3 and 5 over 3, and the third row will be equal to, the third row will be, we have 0 and 0 here, and then 1 here, because we are multiplying by 9 over 32, and but this number will change it into 256 over 9 and times 9 over 32. So this will be equal to 9 and 9 are simplified. Then we have 256 over 32, and this is equal to 8. So we get 8 here. Yes, and we are almost done. Since we already have zeros, these are zeros, and we have ones, pivots. The pivots are already ones. Now we can go ahead and find x and y and z. And we can start from z. We have from the third row here, from this row, we have z equal to 8. Z equal to 8. And we can insert this z equal to 8 into the second row. If we insert it into the second row, what will we get? We will get x is equal to 0. Then we will get y. This is y. and minus 2 over 3 times z, which is equal to 8, and then this will be equal to 5 over 3. So from this, what do we get? We get y equal to 5 over 3 and plus 16 over 3, which is equal to 21 over 3, which is equal to 7. We get y equal to 7. We have y equal to 7, y equal to 7, and z equal to 8. So if we take this y equal to 7, we take y equal to 7 and z equal to 8, and we take both into the first line. If we insert them into the first line, what do we get? What do we get? We have x, because we have 1 here, this. So we have x and plus 2 over 3 times y is equal to 7, and minus 4 over 3 times z is equal to 8, equal to minus 3. And from that one we can get x. So x will be equal to minus 3 and minus 2 times 7, this is 14, not 17, 14. This is 14 over 3, and minus, then in the other side this will be plus 4 times 8, this is 32, then over 3, and if we could put them on the common denominator, we will get x will be equal to then we have 9, right? No, the common denominator is 3, then 3 times minus 3, this is minus 9, minus 14 and plus 32 and over 3, and what do we get? We get x equals to, this is minus 23 plus yes, this is 9 over 3, and finally we get x equal to 3, and then we get our solution. And when you solve a system, you always need to write the set of solution, and if S is the set of solution, the set of solution will be equal to this point, x equal to 3 and y equal to 7 and z equal to 8. So this is the solution. Isn't it good? Yes, very good. So the next question is question number 8. Is it? No, question number 9. Question number 9. It says, write 3 terms of the Maclaurin expansion of the function f of x equal to ln of 1 plus e power x. Yes. Manu mwateguye kino kizamini hano mwashizemo ikosa ex. If you use big X, use big X wholes. If it's small x, then it should be small x. Yeah. So, but it's okay. They need that we write 3 terms of the Maclaurin expression for this function f of x equal ln of 1 plus e power x. So how do we do this kind of question? The Maclaurin expansion or Maclaurin series. This is a particular form of the Taylor expansion. But do you remember how to write Taylor expansion of a function? We have our function f of x equal to ln of 1 plus e power x. This is our function. And in general, the Taylor series or Taylor Taylor expansion, sorry, the Taylor series or Taylor expansion series, I don't know if I'm writing it well, series, yes, series, yes, it's of the form summation n from 0 up to infinity of the derivative of a function of order n in a given point a and times x minus that point a power n over n factorial, and n belong of course in then in n set of natural numbers in n, yes. And this is the Taylor expansion. For the Maclaurin expansion or Maclaurin series, it is a particular form of the Taylor expansion where a is equal to 0. So if a is equal to 0, the series becomes summation of fn, this is the derivative of order n, then in 0, and then times x minus 0 power n over n factorial. Then summation, of course, n from 0 to infinity. So this will be equal to summation n from 0 to infinity of f derivative, or not derivative, derivative of order n in 0 and then times x power n over n factorial. So this is the general form of the Maclaurin expansion. So if they only need three terms, it means they need n equal to 0 and n equal to 1 and n equal to 2. Only 3 terms. And if n is equal to 0, if n is equal to 0, we will have f of 0, we are not differentiating, then times the x power 0 over 0 factorial. Then in our function, we will get f of 0, it will be ln of 1 plus e power 0, yes, and then times x power 0 is 1 over 0 factorial is 1. Then this will be equal to ln of 1 plus 1, which is equal to 2, ln of 2, for n equal to 0. And for n equal to 1, for n equal to 1, we will have f derivative, the first derivative of 0 times the x power 1 over 1 factorial, which is equal to f derivative of 0 times the x. So we need to compute f derivative of 0. The first thing that we need to do is to differentiate our function. Sorry. So if we have f of x equal to ln of 1 plus e power x, then what will be its derivative? Derivative of f of x will be equal to ln of 1 plus e power x and derivative. How do you differentiate a ln of a given function? What is the formula? I write it up there. If we have ln of a given function f of x and we want to differentiate it, this should be equal to f derivative over f of x. So we are going to use this formula we are going to use this formula to compute our derivative. And then if we use that formula and compute our derivative, we will get f derivative of x will be equal to 1 plus e power x and derivative over 1 plus e power x, right? Yes. And this will be equal to what? And this will be equal to 1 derivative is 0 and e power x derivative is e power x, then over 1 plus e power x. I think you understand why I say that e derivative is equal to x, because e power f of x derivative, any kind of this form, is equal to f of is equal to f derivative of x times e power f of x. This is the relationship. Then e power x derivative, this is equal to x derivative times e power x, times e power x. E power x, then x derivative it's 1, then e power x. Yeah, so that's what I have been using, this one. And then since we have our first derivative, now we can compute the derivative in point x equal to 0. Then we have f derivative of 0 is equal to e power 0 over 1 plus e power 0. This is equal to 1 over 1 plus 1 equal to 1 over 2. That's good. And then we insert this 1 over 2 in here. So the second term will be 1 over 2 x, yes, x. This is the second term. Yes, and the first term was this one, this ln of 2. This is the first term. Yes, and then we need to compute the third term. How do we compute the third term? To compute the third term, we need to compute it for n equal to 2. So if n is equal to 2, we have f second derivative of 0, then times x power 2 over 2 factorial, like this. So what we need is to compute this second derivative. And the second derivative, we should differentiate this one. So let's differentiate that one. We have that the second derivative of our function f of x is equal to e power x over 1 plus e power x and derivative. Do you remember how to differentiate a fraction? If we have, the formula is this, if we have u over v, this is v, and we want to differentiate this fraction, this is equal to u derivative times v minus u times v derivative over v squared. Yeah, that's the formula that we need to use down here. And if we use that formula, what do we get? We will get that this is equal to e power x derivative times 1 plus e power x and minus e power x times 1 plus e power x derivative over 1 plus e power x and squared. So then this will be equal to e power x derivative, it is e power x, then times 1 plus e power x and minus e power x and times one derivative, it's 0 e power x, derivative it's e power x, then times e power x over 1 plus e power x and squared, which is equal to e power x minus e power 2x minus e power 2x, and this are simplified, then simplified, and we get e power x over 1 plus e power x squared. So we have sorry so we have, I need to drink some little bit water. Yes. So then f derivative, second derivative of x is equal to e power x over 1 plus e power x and squared. Then if we evaluate this derivative in x equal to 0, we will get f second derivative of 0 equal to e power 0 over 1 plus e power 0 then power 2, which is equal to 1 over 1 plus 1 power 2, 1 over 4. Yes, and then the third term will be, we take this 1 over 4 and we insert it in here. We replace it by this 1, and then we get this, the third term to be, the third term will be the third term will be, it was f second derivative of 0 x squared over 2. So then it will be equal to, we replace this by this number, then it is 1 over 4 times x squared over 2, which is equal to 1 over 8 x squared. This is the third term. Yeah. And if you want, you can write your Maclaurin expansion. Then you will say that ln of 1 plus e power x is equal to the first term. The first term was ln of 2, yes, and the second term is, let me see what it is 1 over 2x. Yes, then plus 1 over 2x and plus 1 over 8x squared plus, and so on. So that's the expansion, and we only needed these 3 terms, and we can easily say ln of 1 plus e power x equal, it's approximately equal. If we want to leave other terms, then we will say that it's approximately equal to ln of 2 plus 1 over 2x and plus 1 over 8x squared. So that was it. That was the answer that they needed. Wasn't it easy? Biba byoroshye, ntimukagira ubwoba rwose, ni ukuri ikizamini muzagitsinda. It is easy. Relax and study. Train yourself and get ready for the exam. Exam is easy. Don't be worried. Okay, then that was it for this question. Now let's move on to the next question. The next question is question number 11. Question number 11. Let T defined from R power 3 to R power 3 be a linear transformation such that T of this vector is equal to this, the image of this vector is equal to this, image of this vector is equal to this one, and then find the image of this. Yes, we have okay, let me find the paper so that we can handle this equation. Yes, yep. Let me first write the vectors. We have t of 1, 0, 0 equal 2, 4 minus 1. We have t defined from r power 3 to r power 3, and t of 1, 0, 0 is equal to 2, 4 minus 1, 2, 4 minus 1, and t of 0, 1 and 0 is equal to 1, 3 minus 2, 1 and 3 and minus 2, and t of 0, 0, 1 is equal to, this is equal to 1 minus 2 and minus 2. 1 minus 2 minus 2. So, and we are asked to find t of 0 and 3 and minus 1, wasn't it? Find this one. T of 0, 3 and minus 1. And we have been told that, let me make this one bigger, yes. And we have been told that this function t is a linear transformation. A linear transformation. Linear transformation. What does it mean? This is a linear transformation. If it is a linear transformation, what does it mean? What does it mean? It means that being a linear transformation, it means that t of n on two vectors u plus v should be equal to t u plus t v. That's the first row, and this is first property. This property is said it is called the additivity. This is additivity property, additivity property. And the second property is that it admits the scalar multiplication property, t of n vector times a, where a belongs to a set of real numbers. This should be equal to a times t of u. So this is a property called the scalar multiplication property. Scalar multiplication, yes. If it is a linear transformation, it satisfies these two properties. Yes, and we remember that we are in R3, and in R3 n vector u, which belong to R3, it is the let's suppose that u, it has coordinates x and y and z. So this vector is defined by x times e1 and plus y times e2 and plus z times e3, where e1 equal to what, and e2 equal to what, and e3 equal to what. Where e1 is this vector 1, 0, 0, and e2 is the vector 0, 1, 0, and e3 is the vector, which vector? 0, 1, 0, 0, and 1. Yes. So in this case, we have e1, we have t of e1 up here. We have t of e1, this is e1, and this is e2, and this is e3. And this is, suppose that this is the vector u of x, coordinate x, y, y and z. So we have a vector u of coordinate 0 and 3 and minus 1, which means that this vector should be equal to 0 times e1 and plus 3 times e2 and minus 1 times e3. Right? Yes. So then what do we have? We have that since this T is a linear transformation, the image T of u should be equal to T of 0 e1 plus 3 e2, right, minus 1 e3, yes, and this is equal to 0 T of e1 because it is a linear transformation, and plus 3 times T of e2, right, yes, and minus 1 times T of e3, like this. Yes. So what do we have? We have T of u equal to 0, 0, it's 0, of course. It's 0 times T of e1. T of e1 is given to be this. We have it up there, 2, 4, and minus 1. We have 2, 4, and minus 1. So then 0 times 2, 4, minus 1, and plus 3 times T of e2. T of e2 was 1 and 3 and minus 2. And minus 1 times T of e3. T of e3 is 1 and minus 2 and minus 2. Then we add those points together. If you add them together, what do you get? You get 0 times 2 is 0, 3 plus times 1, that's 3. Then minus 1, we have 2. The first component is 2. And the second component will be 0 times 4, that's 0. 3 times 3, that's 9. And minus 1 times minus 2, that's 2. Then 9 plus 2, that's 11. We have 11. And the third element, that's 0. 3 times the minus 6. And plus 2, then minus 6 plus 2, was it minus 6? Yes, minus 6 and plus 2, then this will be equal to 4. Was it 4? Yes, I get 4. So if I have computed it well, I get our image T of u, which was T of 0 and 3, 1 to be equal to that one. So that was it. Again, we didn't need again ntabwo ibi bintu byose byo nanyuzemo rwose ntabwo twari tubikeneye, ngiye nabinyuzemo kugira ngo ubibone. Niba wari usanzwe ubizi, I'm sorry, ariko ku batari babizi buriya barabibonye. Icyo twari dukeneye, it was only this one, these lines, these two lines, T of 0, 3, 1, like this, equal. We only needed these two lines. Donc igisubizo cyari muri iyi mirongo ibiri gusa. Okay, right. So that was it. Wasn't it easy? That was question number A. And do we have question number B on this equation? I don't know. Yeah, it was only that one. So we are done. Then next equation, we are asked to verify if T defined from E squared to E squared by this is linear or not linear. Okay, now from this question that we have been solved, duhere ku kibazo tumaze gukora hano haraguru, twamaze kubona what is a linear transformation and what is a non-linear transformation. So what we need muri iki kibazo cya 12 is to verify the two properties, additivity and scalar multiplication, tukareba niba ziri satisfied. If they are satisfied, this function will be, or this transformation will be linear. If they are not satisfied, this transformation will be not linear. Reka wenda duhere kuri scalar multiplication. I think it will be easy. We have our function t. Sorry for the noise. I think you are still following, even if it's a little bit noisy, but I think you are still following. We have our transformation t defined from, this is t, from e squared to e squared by t of n couple x1, x2 to be equal to, make this one bigger, to be equal to x1 plus x2 and x1 minus x2 plus 1. This is our transformation, and we need to know if it is linear or not. Okay, suppose that we have a vector u of coordinate x1 and x2. So now I want you to compute the value of, if we have a times u, and we need to compute its image. So we have, is it equal to a times t of u? That's my question. If it is, then the scalar multiplication property will be satisfied. If not, then that property is violated. If it is violated, then the function will no longer be as a linear function. So let's go ahead and compute this and see. We have u equal to this one. Then what is a times u? A times u, of course a belongs to R. It's a real number. So a times u will be equal to a x1, right? And a x2. This is the point. And if we compute t of au, will be equal to what? It's t of a x1 and a x2. And this will be equal to what? We have to use this relation. This relation for x1, x2, we have this. Then for ax1, ax2, we will have a x1 plus a x2, and the second component will be a x1 minus a x2, then plus 1. Yeah. So, and this is equal to a times x1 plus x2, right? Yes. And the second component is a times x1 minus x2, but we don't have a in here. So then plus 1 over a. So this is the image, and then this is equal to a times x1 plus x2 and x1 minus x2 and plus 1 over a, like this. So you see, is this equal to this one? No, they are different, because this one is totally different from this one. So since they are different, this is different from t of x1, x2. These are different. So therefore, we have t of a u is different from a t u. Since they are different, then the scalar multiplication property is violated. Since the scalar multiplication property is violated, then therefore t is not linear. We don't need to verify the second property since the first property is already violated. Our function is not linear. That was it. Wasn't it easy? Yes, very easy. So let's move on. So let's move on to the next equation. Next equation, it's question number 13. It says this: suppose that you are observing the behavior of cell duplication in a laboratory. If in one of the experiments you started with 1 million cells and the cell population decreased by 10% every minute. A. Write an equation with base 0.9 to determine the number of cells after 10 minutes. And B. Determine how long it would take the population to reach a size of 10 cells. Okay. So we are in a laboratory. You scientists, you are in a laboratory and you are observing how cells will duplicate. And you start with 1 million cells. Okay, ufite cells 1 million cells and you are observing how they duplicate, and it is said that nyuma y'umunota umwe haba hamaze kugabanuka cell watangiranye ziba zimaze kugabanukaho 10%. Ubwo izisigaye nyuma y'umunota umwe ni zingahe? Icyo ni kimwe. We have the starting population. Let me say P0. It's 1 million. 1 million cells. 1 million cells. And after 1 minute, it says that after 1 minute, this is 1 minute. 10% is gone because they are duplicating. Is gone. If it is gone, what is the remaining? It's like each minute. Let me write this. Each minute. Buri munota. Each minute. The remaining population. The remaining population is we have if we start by P0 and 10% of P0 is already gone, then the remaining will be equal to P0 minus 10% of P0. So which will be equal to, we have P0 here, and then 1 minus 10%, and this will be equal to P0 and times 1 minus 10% is equal to 90%. Then this is equal times 90%. And what is 90%? 90% is the same as, this is the same as P0 times 0.9. This is in 1 minute. And what if in 2 minutes? Then in 2 minutes it will be P0 times 0.9 power 2. And in 3 minutes then it will be P0 times 0.9 power 3, and so on. So then the equation for this kind of duplication decay, it will be equal to, let me say, call it PT, and where T now it will be minutes, this is the time in minutes, will be equal to P0 times 0.9 and power T. And this was the equation that they asked. This is the equation that they asked. And then the second question was how much time it will take that we will remain with only 10 cells. Then how much time T we need to have PT equal to 10 cells. That's the question. 10 cells. So if we insert this PT, which is equal to 10 cells in this equation, we will get P10 equal to P0 times 0.9 times power T. And we are looking for T. This T equal to what? So we have 10 equal to P0. P0 it's 1 million. 1 million is 10 power 6. Then times 0.9 and power T. And then 10 and 10 power 6 is simplified. We have here 10 power 5. Then we have 1 over 10 power 5 equal to 0.9 power T. Yes. And then how do we get T? If we apply the natural logarithm both sides, we have ln of 1 over 10 power 5, it's like 10 power minus 5, ln of 10 power minus 5, then this is equal to ln of 0.9 power T. And then this is the same as minus 5, ln of 10, yes, and this is equal to T times ln of 0.9. Then T will be equal to minus 5 times ln of 10 over ln of 0.9. Yeah, so that was it. If you have a calculator, you can compute these values, and these values will be approximately equal to what? Just take a calculator and compute this one. I computed this, it was 0.09 I don't remember if it's 27 something. Yes, units. So it would take 109.27 units to have only 10 cells. And that was it. So wasn't it easy? The question was very easy. So guys, don't be afraid. Ikizami kiba cyoroshye, don't worry, wikuremo ubwoba, utegure ikizami cyawe neza, ubundi intsinzi ni yacu, intsinzi hejuru cyane. So let's move on. Next question. We are almost at the end of this section, and the next question, it was question number 14. Given that we have 3 lines, y equal to 2x plus 1 and y equal to 3x plus 1 and x equal to 4. Find the coordinate points of intersection of the lines, and then sketch a graph of the given lines in the same 2 dimensions. Yes. And find the area of the region found in B. Okay. So let's see. Dufite hano imirongo itatu, 3 lines. We have 3 lines, and the first line is y equal to 2x plus 1, and the other line is 3x plus 1, and the other line is x equal to 4. And we are asked to find intersection of each of the 3 questions. This is 2, and then the third line. Let's start by finding intersection between line 1 and line 2. Line number 1 and line 2, we need intersection of these 2 lines. We have y equal to 2x plus 1, and y also equal to 3x plus 1. This is where intersection will be. So from this we can solve 2 x minus 3x will be, we have 2x plus 1 equal to 3x plus 1 if and only if x equal to 0. So if x is equal to 0, what do we get? If x is equal to 0, we get y equal to 1. So the intersection point is the point of components 0 and 1. This is the intersection for the two lines. And what about the intersection between line number 1 and line number 3? So for the line number 3, we have x equal to 4. So if x is equal to 4 and we insert it in line number 1, we will get y equal to 2 times 4. This is times 4 and plus 1. And this is equal to 8 plus 1. This is 9. So we get the point of intersection to be point of component 4 and 9. Right? Yes. And what about the intersection between the line number 2 and line number 3? The intersection will be based on the fact that x is equal to 4 and y is equal to, now it will be 3 times 4 and plus 1. Then 3 times 4 is 12. Plus 1 is equal to 13. Like this, right? Yes. And then the point of intersection is, in this case is the point of component 4 and 13. That was it. This point, and this point. This is the 3 points that they asked in question number A. And the question number B, they want us to sketch these lines. Oh my God, am I going to be able to sketch? Anyway, we try. Reka ngerageze. Ariko nyine gushushanya hano ntago biri buze gupfa kunyorohera. Gushushanya nta rati. Oh, in your case, when you are sketching these lines, please use a ruler. Muzashushanye nabi nkuko ngiye kubishushanya nabi. Muzabishushanye neza kuko mwebwe muzamufite irati. Yewe nta rati mfite rero ngo nimubona bitasa neza nimuncira urubanza. Mwebwe muzashushanye neza kubera kuko muzamuri gukoresha irati. But I'm going to try my best. With these tools, I'm going to try my best. Yeah. Okay. This line is not good. You see? It's difficult for me. Hano ndabona binkomeranye. Let me try again. Try again to make a straight line. At least this one. And then the other line is horizontal line here. Yes, this is x axis and this is y axis, and we need 4 lines. Let me say that this is 1, then 2 and 3 and 4. So if I have 4 here, then I have a line which is going to pass here. A line is, yeah, this is x equal to 4, but sketch it well with your ruler. With your ruler, so please sketch it well. And we have 1 here. One point of intersection for our lines is this point of component. This is the point of component is 0, 1. 0, 1. And also we have 1, 2, and 3, and 4, 5, 6, 7, karivugire mu Kinyarwanda 8, 9. So we also need the point of component 4, 9. This is another point of intersection. Sorry, this one is 4, 9. Yes, we also need, this is 10, 11, 12, and 13. This is 13. This is 9. Yes, and we also need this point. This is the other point of intersection, point of component 4, 13. And one of our line will pass here, on these 2 points. Yes, and this line is the line of equation 2x plus 1, and the other line will pass here. Yes, wow. Here, and this is y equal to 3x plus 1. Please sketch these lines well. Mwege muzarushanye neza kuko muzamufitira ati ko ngiye murabona birigondoye. Birigondoye ariko nimuzabigondorere. It will be a straight line. Make straight lines. Yes. So that was B. And then C bavuze ngo dushake the area of the area obtained. So, area bordered by these points. We have point 01, point 49, and point 13, 414. So we need this area. Turashaka ubuso bw'iyi area. Burangana bute rero? Burangana bute? How do we compute this area? Gira ngo niba mubireba neza mwibuka neza ko mwabyize hano twakoresha integrale, ngiye nizo ziri bunyorohere. Hari n'ubundi buryo umuntu yakoresha ariko ngiye I'm going to use integrals. That's easiest one. We need to integrate. If we integrate this line y equals 3x plus 1, we will be finding which area. Let me use this color. If we integrate this line, we will be finding this area or this area. Yes, or this area. But if we integrate this line 2x plus 1, we will be finding which area? We will be finding only this area, the blue one. So what we need, we only need, I'm going to call it, let me find another color, like use green one. We need this area S, this S, and S will be equal to what? Let me compute it here. S, it will be equal to integration from, we are integrating from 0 here to 4. We have 0 here and 4 here. So we are integrating from 0 to 4. And what are we integrating? We are integrating 3x plus 1 and minus 2x plus 1. That's what we are integrating, and dx. Yeah. Niko twabona buriya buso. So let's do it. So this will be equal to integration from 0 to 4, and 3 minus 2x, this is x, 1 minus 1, it's 0, then dx, like this. And this is equal to 1 over 2 x squared, yes, and then from 0 to 4, like this. And this is equal to 1 over 2 and 16, yes, and minus 0. And this is equal to 8. So S is equal to 8. Our area is 80 meters of area. If it's meters, square meters or square kilometers, I don't know, depending on what we have been given. But we have not given any meter, so then I assume that it's a given meter. It's a given meter of area. So we have 80. That was it. Wasn't it good and easy? And this looks very nice. byari ibyo ngibyo. Reka turebe icyanyuma. Icyanyuma se tubirangije? Turabirangije. So icyanyuma cyavugaga the last one, find the constant c such that the function f of x equal to c squared when x is between 0 and 3 and 0 otherwise is a density function, and then compute the probability that 1 is less than x less than 2. Probability density function. What is a probability density function? If a probability, we have f of x, yeah, I need a black color. Yes, we have our function f of x equal to c times x squared. We have the same x, of course, x squared when 0 is less than x and less than 3 and 0 otherwise. And they say that this is a density function. If f of x is I'm using this x is a density function. If f of x is a density function, what does it mean? If it is a density function, then integration from minus infinity to infinity of f of x should be equal to 1, because the sum of probabilities is equal to 1. Right? So then, using this relation, the fact that it's a probability density, now we can find the value of c. Then we will have integration from infinity to infinity of f of x dx. Here I'm missing dx, of course. Dx will be equal to integration from minus infinity to 0 of f of x dx, and plus integration from 0 to 3 of f of x dx, and plus integration from 3 to infinity plus infinity of f of x and dx. So and this part is equal to 0, and this part also is equal to 0, and this one is equal to cx squared. F of x here is equal to c, this is equal to 0, of course, but here we have f of x equal to cx squared. So then we will have integration from 0 to 3 of cx squared dx equal to 1 if and only if 1 over 3 c x power 3 and from 0 to 3 equals to 1. And what do we get? We get 1 over 3 c x power 3 power 3 is equal to 27, and then 0 minus 0 equal to 1. Then we get c equal to 1 over 1 is equal to 3 over 27. Yes, and then c equal to 1 over 9. That was C. That was A. We have gotten C. C was supposed to be 1 over 9. That was the answer. And in B, we were asked to compute the probability that 1 is less than x and less than 2. So this is equal to integration from 1 up to 2 of f of x dx. and this is equal to, and this is equal to integration from 1 to 2 of f of x. Now we replace c by its value. It's 1 over 9 x squared dx. So this is equal to 1 over 18. Is it 18? This is 27. Was 9 times 3, that's 27. Yes. 1 over 27. 27 times x power 3, and from 1 to 2. Yes. And this will be equal to, this will be equal to 8 over 27 minus 1 over 27, and this is equal to 7 over 27, and that was it. That was it. Probability that 1 is less than x and less than 2 should be equal to 2 over 27, and that was it. And this is the end of section number A. Bravo! And we are ready to hit the exam, and we are passing all. Okay. Ubwo rero next time we will be starting solving section number B. Tuzatangira gukosora section number B next time. I don't know if it's next week. It should be next week. And ndifuza ko muri section number B, kubera kuko ibibazo byo muri section B akenshi bifata iminota myinshi mu kubisobanura. Wenda uri kubikora gutya nta muntu uri gusobanura bishobora gutwara iminota mikeya, ariko iri gusobanura bifata iminota. Byazaba byiza tujye dukora ikibazo kimpa ya video. One video, one question, one video, one question, one video, one question. Or at least 2. At most, let me say at most. Byaba byinshi bikaba bibiri kugira ngo video ibe ntoya, kuko izi video maze imisi ndi gukora ni video ndende, nzi kuko biborohera kuzireba. Ariko please try your best and watch these videos. They are very useful, and share this video to your friends. Yes, mubabwire baze twitegura ibi gutsindikiza. Muntu ugera ku kintu atakoreye, mureke twige dushizeho umwete dushishikaye, ubundi tuzatsinde neza. Bifurije amahirwe masa. Good luck. Bye.